Right, if I just explain the setup I've got. This is Paint. The screen capture is actually recording everything I do on Paint. Into my laptop I've got plugged a graphics tablet. This is in fact an A5 size graphics tablet, which is sufficient for most things. And my voice has been recorded by a simple, fairly straightforward cheap microphone. Okay, so let's start. So what I'm doing is I'm drawing directly onto the graphics tablet, and what I write down appears on the screen. It takes a little bit of hand-to-eye coordination, but once you get used to it, you get better. So let's start off. Let's have some sort of inorganic chemistry, maybe a complex. This is an iron 3 complex, X-aqua. Okay, that's pretty easy to do in a graphics tablet. Pretty horrendous to do on Word or whatever. What with all these superscripts, subscripts, square brackets, round brackets. So we'll do a substitution reaction. Okay, then we could sort of narrate as we're actually doing it. That's obviously iron 3 plus, surrounded by 6 cyanides, each with 1 negative, resultant charge of 3 minus. Where's the waters gone? Here they are, being kicked out. Okay, so that's a fairly straightforward example. One great possibility, I think, is actually explaining maths, derivation of equations, rearrangement, particularly an area of weakness of students, and maybe even going into integration, differentiation. So let's take a first order rate. As an example. Okay, we can define first order as that. If we want to go to the integrated rate equation, we'd have to explain that we gather like things on each side of the equals sign. So however we're going to do it, multiply through by a, multiply through by delta t, etc, etc. But the upshot is this. And then we could explain that we need to integrate that, so put the integrations in. And one there. And then the limits, so obviously going from t0 to a time t, and concentration from initial concentration to a particular concentration at a particular time, etc, etc, etc. Another powerful possibility, I think, is actually doing mechanisms where it's like a slow reveal rather than just a complete solution. So just making a very simple example here because I'm running out of space. Maybe take up a nucleophile and a carbonyl. Okay, there's your carbonyl. We could explain that due to electronegativity we get that kind of polarization. Here's our nucleophile, hydroxide, lone pair, negatively charged. Lone pairs coming into the slightly positive carbon, bond breaks to produce this. Lone pair on oxygen, and so on. Another possibility is graphical work. Say for example, a tutorial problem which represents maybe plotting a graph, interpreting a graph, putting on lines of best fit, whatever. It's difficult to actually draw perfect lines using a graphics tablet, so I can actually use the line tool in Paint to give me a set of axes. Okay, once I've established that, I'm now switching to the graphics tablet to put my points in. I'm actually using a piece of paper over the graphics tablet where my points are drawn in just as a guide. It's sort of, again, really we should be on the paintbrush tool rather than the pencil. So I'm just going over the paper, if you like, tracing out the points. Okay. And then I can add a curve of best fit. perfect, but there we are. I can now change my colour, switch to a red paintbrush, and then we can do some kind of extrapolation perhaps. Going up from the x-axis, going to the y-axis, and so on. Maybe change to blue, make some kind of points, pointing out anomalous results or drawing attention to something, etc, etc. Okay, so a simple graph. I'm going to make it more complex. Obviously we can put axes labels on there. I'm just putting a y and an x, and we can actually even have a scale. Again, you could set this up beforehand, before you're actually making your recording, and again making reference to a piece of paper just to keep things accurate. Okay, so that's a graph. In this instance, what I've done is opened up a simple proton NMR spectrum of ethyl acetate in Paint again. I've also superimposed on that a ChemDraw sketch of the molecule, and what I'm going to try and do is actually link the peaks and splitting patterns to the actual structure. Okay, for example, we can pick out the singlet, this one here, at about 2, and we can relate that to these 3 protons with no non-equivalent neighbours. Okay, the quartet centered at about 4.2. Obviously it's got 3 non-equivalent neighbours, so you can actually associate it with this, and again looking at the chemical shift values would be consistent with that particular assignment. Finally, the triplet are the remaining protons, the methyl group. We could sort of embellish this a little bit further, explaining why we do get a quartet, perhaps by splitting the peak once, twice, 3 times to give us the 4 peaks. And by Pascal's triangles you can get the relative intensities.